Hello, everyone, and welcome back to another lesson on our CompTIA A Plus course. In today's session, we're going to break down some of the most common network configuration concepts, things you'll not only see on the exam, but also encounter constantly in real-world IT environments. Let's start with DNS, or Domain Name System. You've probably heard of it as the phone book of the internet. It takes domain names like www.amazon.com and translates them into IP addresses that computers can use to connect with each other. But DNS isn't just one giant list. It's made up of different record types, and each serves a specific purpose. First, there's the A record, which maps a domain name to an IPv4 address. For example, it might translate mywebsite.com to 192.0.2.1. Then we have the 4A record, which works the same way, but maps to an IPv6 address instead. Next is the canonical name record. This creates an alias for another domain name. So if you want blog.example.com to point to www.example.com, a canonical name makes it happen, keeping your DNS records clean and manageable. And then there's the MX record, which stands for Mail Exchanger. MX records tell the world where to deliver email for your domain. If your company uses Microsoft 365 or Google Workspace, their mail servers will be specified in your domain's MX records. Now, let's move on to DHCP, the Dynamic Host Configuration Protocol. This service automatically assigns IP addresses and other network settings, like subnet masks, gateways, and DNS server info, to devices when they join the network. One key concept here is a lease. When a device receives an IP address from DHCP, it's not forever, it's a lease. After a certain amount of time, the device must renew the lease to keep the IP. This helps prevent IP conflicts and keeps your address space organized. But what if you want a specific device, like a printer or server, to always get the same IP? That's where DHCP reservations come in. A reservation matches a device's MAC address to a specific IP, ensuring consistency without static configuration on the device itself. Now let's zoom out and talk about virtual local area networks. VLANs allow you to logically segment your network, even if all your devices are plugged into the same switch. For example, you might have one VLAN for HR, another for finance, and another for IT, each with their own security policies and broadcast domains. Finally, let's discuss VPNs, or virtual private networks. A VPN creates a secure, encrypted tunnel between a user's device and a remote network. It's commonly used by remote workers who need to safely access company resources over the internet. In summary, mastering DNS records, DHCP leases and reservations, VLANs, and VPNs gives you the building blocks for designing and supporting networks. Whether you're mapping domain names, assigning IP addresses, segmenting your environment, or securing remote access, these configuration concepts form the foundation of everything that happens on a network. Thank you for joining us today, and see you soon.